Cool. So it's time for us to think about how the multiplication of algebraic fractions actually work, right? So before coming on to that chopping part and all, we will do a simple problem, right? With numbers. So we will begin ourselves with numbers. Right? Beginning with numbers always have a kind of a satisfaction with us because the numbers is what makes us easy to think. So we will think about the numbers initially. For example, suppose if I have half into half, right? So half into half. The multiplication is of course very easy. What you have to do is you just have to multiply the numerator separately. You have to multiply the numerator separately as you do the normal multiplication. That's very simple, right? So you have the numerator and the numerator is somewhere around here. So 1 into 1 is going to be 1. 2 into 2 is going to be 4, and this is how it works, right? It's very simple, right? For example, if you have 3 over 5 multiplied by 2 over, let's say 2 over 7 or something else. So here, you have to multiply the numerators separately and the denominators separately. So if I suppose to multiply the numerators separately, 3 into 2 is going to be 6, simply 6, and 5 into 7 is going to be about 35, right? So it's going to be 35, right? So this is how the multiplication of algebraic terms, algebraic fractions work. Right? Now, what if we involve algebraic terms into this? That's why we say algebraic fractions. We don't just say fractions, multiplication of fractions, division of fractions. We don't say that. But rather, what we are going to say is, we say that algebraic fractions, multiplication, division, and all these kinds of things are going to work with algebraic terms. So to do with or deal with algebraic terms, what we have to do actually is, for example, let us think about a problem like this. 2 divided by x multiplied by y over 3. Suppose if I have a problem like this, what you have to initially do is, initially you multiply the numerator separately and you have to multiply the denominator separately. Please mark the word separately, because you have to multiply numerator, all the numerators together. 2 into y is going to be simply 2y, and x into 3 is going to be simply 3x. So this is how it works, right? Now let us think about how the chopping part works. We will think about how the chopping part works. For example, if you have let's say x over we'll move on with numbers initially. So if you have 2 over 8 multiplied by 4 over let us say 5 or something else like this. Now you have to see by what number this 2 and 8 can be divided. Can you divide this 2 and 8? And if that is the case, you should have an LCM. You should have a common term. Not the LCM. Sorry about that. You have to have a common term, right? So 2 and 8 is there, right? You can divide 8 by a number, right? And 2 also by the same number. Then you can chop each other. Look at this. 2 can be divided by 2. 2 divided by 2 is going to be 1. And 8 divided by 2. 8 also can be divided by 2, because 8 divided by 2 is equal to 4. So when that is the case, 2 divided by 2 is going to be 1 here, and 8 divided by 2 is going to be 4 here. So you can cut them and you can put the numbers there. Now the next thing what you are going to do is, 4 and 4 can be chopped. Why is that? Because 4 can be divided by 4 and 4 can be divided by 4. Because 4 divided by 4 is equal to 1. So when that was the case, instead of this 4 you are going to get 1 here. You don't have to put this 1 because it doesn't make any sense, because 1 into 5 is still 5. So no matter even if you put that 1 or even if you don't put that 1, it's not going to make a change for this entire problem. So 4, since you have cut this 4, you have to cut this 4 as well. So you are going to get 1 here. 1 into 1 is going to be 1, and 1 into 5 is going to be 5. So the answer will be 1 over 5. So if you have a problem like this, the only thing involved here is the algebraic term. So you have only algebraic terms. If that was the case, you have numbers as well, but algebraic terms are involved here. So you have to think how to do this kind of problems, right? X into 4, right? X into 4 is how much? If you have toffees and if you multiply the toffees by 4, it's going to make you simply 4 toffees, right? So you don't say toffee 4, but you say 4 toffees. Right? So we always try and give the priority to numbers, right? So we have to write the number in front, right? It's not a must. It's not a must, but that's the tradition of writing the way. That's the tradition, right? So x into 4 is going to be 4x divided by y into 5z, right? So y into 5z is going to be, now y 5z. So we are going to give the number the priority. So you're going to get 5 here, and you can write it as 5zy or 5yz. Doesn't matter how the way you write it, right? Similarly, if you have let us say a problem like this, x into 4, we will say x over yz multiplied by 4z over let us say x or something else like this. If this was the case, how are we going to do this problem, right? So how are we going to do this problem? So here you can remember how we chopped when you have numbers. If you have 4 and 4, right? Last problem that we have discussed, 4 and 4, you can cut that 4 and 4 and you can put 1. Similarly, you have x here and x here, so that you can cut them, x and x, and you can put 1 there, right? So x to x gone, you're going to get 1 here, x to x gone 1 here. Look at this z and z also gone, and you're going to get 1 there. So the answer will be, nothing is remaining except this 4, so you put 4 divided by, nothing is remaining down, so you're going to put y there. This is how it's going to work, right? Now we will think how the powers, if you have the powers, index form is there, how are we going to deal with problems like that? So that is what now we are going to think about. So for example, if you have x squared y multiplied by 3x over 4y cube, let's say you have z here, and let's say z squared there, right? So how are we going to solve this? So here's the problem. Now z squared, what is z squared? Z squared means z into z. So z into z can be divided by z, right? Because 2 into 2 is 4, right? 4 can be divided by 2. 2 into 2 can be divided by 2, right? So similarly, z into z can be divided by z. If you cancel z into z by one of the z's, one of the z's is going to cancel here, and one of the z's is going to cancel here, and one z is going to remain there. Right, so hope you are understanding and concentrating what I'm saying, right? Please concentrate this carefully. And if you have y and y cube, right? Y cube, what does that mean? Y into y into y. So you have x squared y over 1. Now you don't have this z multiplied by 3x z over 4. Y cube is going to be y into y into y. So you can cut one of the y's. So y to y gone. Now from the power rule, you know that x squared into 3x, right? Because 3 and x can be multiplied, so you're going to get x squared and x can be multiplied, so you will get 3x cube. So the answer will be 3x cube, and z is also remaining, so you're going to get z there, and divided by 4y squared. So this is how algebraic fraction works. Maybe I'll upload the tutorials in the group by by 2 days. Just give me about 2 days. By 2 days I'll upload all the problems, and we will try and slowly discuss the problems.